That's the next part that we want to do. So convolution theorem. Let me share my screen again and put the convolution theorem up here. Convolution theorem. Okay, here's what it tells you. 2 parts, because we always have a forward direction and a backwards direction. First of all, the Laplace transform of the convolution of f of t and g of t is equal to capital F of s times capital G of s. So if you are doing a convolution inside of a Laplace transform, you can multiply the answers. Similarly, and this is the part that's useful because it helps with step 3 and going backwards, the inverse Laplace transform of capital F of s times capital G of s is the convolution of little f of t and little g of t. That's the part that's useful. So inverse transform of 2 functions multiplied together is the convolution of their pre-images, kind of, sort of. You can think about pre-images as the function that they came from. Let me do an example and show you why this is useful. So, for example, let's say that we're jumping into the middle of the problem again. So capital X of s is 1 over s squared plus 9 quantity squared. Capital X of s is 1 over s squared plus 9 quantity squared. Yes, I understand that this is in the front of your book and you could look it up, but we are going to demonstrate the convolution theorem and we are going to demonstrate that the answer in the front of our book is actually correct. So I can write this as 1 over s squared plus 9 times 1 over s squared plus 9, right? I can totally multiply those 2 together. So the first one, they're actually equal to each other in this case, is my capital F of s, and the second one is my capital G of s. So we've got a capital F of s, capital G of s. Those 2 are the things that I'm multiplying together. Front of your book, please. Could you go and look, figure out what little f of t is and what little g of t is? Front of your book, go ahead and look that up, or the chart, wherever you happen to have it. What is little f of t and what is little g of t? So pull out your chart, pull out the front of your book, whatever you need, and figure out what both of those are. Inverse transforms there. One over s squared plus 9. Both of those should go with a sign, right? K is equal to 3 in this case, so we're going to need a 1/3 out in front. So 1/3 sine of 3t, and same thing, 1/3 sine of 3t. Good so far? Any questions on that before we try to do a convolution and figure out what the inverse Laplace transform is? If you've got a question, raise your hand virtually. I don't see any. Okay, so therefore, little x of t is the convolution of my little f of t and my little g of t. In this case, it really doesn't matter which function I plug t minus tau into because they're totally the same function. So this is going to be integral from 0 to t, 1/3 sine of t minus tau times 1/3 sine of tau d tau. It matters not at all which function I plug my t minus tau into. It does not make any sort of difference at all. I lost my 3's. Oh, that's a lot of undos. Let's do eraser instead. 1/3 sine of 3 t minus tau times 1/3 sine of 3 tau d tau. Thank you, my bad. All right, we've got a 1/9 out in front that we can pull out. So let's go up over here, and we've got a messy integral to evaluate. So 1/9 integral from 0 to t, sine of, let's distribute. So 3t minus 3 tau times the sine of 3 tau d tau. I'm going to distribute that 3 through. 1/9 all the way out in front. Integral sine from 0 to t, sine of 3t minus 3 tau, sine of 3 tau d tau. Okay, if we were in class, I would make Seth pull out his trig handout and figure out what this trig identity is equal to. But I won't make you do that, and I'm just going to give you the trig identity. So this is equal to, and this is by a trig identity. Trig identity. 1/9 integral from 0 to t. Here's what we've got. 1/2 cosine of those two things added together. So 3t minus 3 tau plus 3 tau. 1/2 cosine of those two arguments added together minus 1/2 cosine of those things subtracted. So 3t minus 3 tau minus 3 tau, and then a d tau. 1/2 on both pieces. We're going to pull that 1/2 out in just a second. Cosine of the two parts added together, and then minus 1/2 cosine of the two parts subtracted. That is a trig identity that you do not, in fact, need to memorize or remember. And this is probably messier than I would put on a test, but you could have it on a cheat sheet if you wanted to. Okay, we've got a 1/18 out in front. We've got an integral from 0 to t. We've got a cosine of 3t, because those two taus cancel in the first one. We've got minus a cosine of 3t minus 6 tau, and then we've got a d tau. 1, 2, 3 more steps on my piece of paper. That's it, not too bad. 3 more steps on my piece of paper. First integral, cosine of 3t. This has no taus in it whatsoever, right? This has no taus in it. So when I find an integral, this is just like a constant. And it's going to be a 1/18 tau cosine of 3t. It's just a constant with respect to tau. So when I find an integral, I am going to have a tau out in front. Integral of cosine is positive sign, but I've got a -6 out in front here. So I need to have a minus -1/6 sine of 3t minus 6 tau. Think about a u substitution if you want to think about it that way. You want to let u equal the thing inside here, and then your du is -6. So you're going to get a -1/6 out in front. Okay, we need to evaluate from 0 to t. We have 2 negatives that we can make into a positive. So here we go. 1/18. Oh, that 1/18 should be in parentheses, sorry. 1/18 all the way out in front. 1/18, here we go. T cosine 3t plus 1/6 sine of 3t minus 6t. That's my first one, and then I'm going to need to subtract. So t cosine 3t plus 1/6 sine of 3t minus 6t, and then minus t cosine 3t, 0. Let's try 0. 0 cosine 3t, 0 cosine 3t, so that's going to go away, plus 1/6 sine of 3t minus 0. I need one more parenthesis. 2 more lines, I promise, and that's it. Just 2. So we've got a 0 cosine 3t. That part totally goes away. That part goes to 0. Let's do some simplifying here. 1/18 is still all the way out in front. T cosine 3t plus 1/6 sine negative 3t minus 1/6 sine of 3t. T cosine 3t, I've got a 1/18 out in front. T cosine 3t plus 1/6 sine of negative 3t minus 1/6 sine of 3t. One more trig identity, sine of negative kt, you can pull a negative out in front. So sine of negative kt is negative sine of kt. That's because kt is an odd function. So you can pull a negative out in front, and I lied to you, it's 2 more steps instead of 1. 1/18 t cosine 3t minus 1/6 sine of 3t minus another 1/6 sine of 3t. So I can pull a negative out in front in that middle piece, and then both of my sine arguments are of 3t. Last step, I'm done now, I promise. 1/18 t cosine 3t minus 1/3 sine of 3t. There's 2 pieces, so 1/6 plus 1/6 is 1/3. 1/18 t cosine of 3t minus 1/3 sine of 3t. This is why we don't do convolutions all that often, but it helps sometimes in finding the inverse Laplace transforms. Sometimes. Sometimes it's just messy, but sometimes it helps. All right, any virtual hand raises before I stop sharing my screen and go back to seeing all of you? Anything there? Stuart, you're one of the few people I can see.
Just to clarify, on the 1, 2, 3, 4, the 5th line, 4th line down.
1, 2, 3 here.
That one, yeah.
Okay.
You get t or tau cosine 3t.
Yes.
Because the cosine 3t, it's essentially just a constant. It's as if it was like a 1, so it would just be 1 tau, but
Right.
instead it's cosine. Okay.
Yep, because you're integrating with respect to tau. Your variable isn't t in this case. Your variable is tau, so you're integrating with respect to tau. Yep, exactly.
Okay.
Okay, Daniel, question.
Yeah. So when we go from like the beginning of the problem on the bottom left
Yep, okay.
side of the corner, like where does the next, how do we go from there to the 1/9? Is that like only one of the integrals, or is that like both of them combined?
That's both. So I've got an integral here, right? All of this is what's being integrated, and this is a multiplication. You can't really tell, but that's a multiplication.
Oh, it's multiplication.
Right? Because if we go back to previous slide, sorry, that looks horrible.
Yeah.
If we go back to the previous slide, actually, if we go back to the slide before that, our definition of convolution here has a multiplication. So sorry, that looked like a minus and it's really times.
Okay.
My bad.
That makes a lot more sense. Yeah. Okay. Thanks.
Okay. Other questions? If you have a other question on this before I start sharing my whiteboard, do a virtual hand raise. Now's the time to ask. This is messy. I completely understand that. Anything else? Other ones? Going once, going twice. Okay. I know I said I was going to stop sharing my screen, but I want to do one more thing first. So here's the thing you want to remember. The inverse Laplace transform of capital F of S times capital G of S is the convolution of the 2 original functions. So, for example, we're not going to work through this one because I don't have it written out, and I'm sure the convolution would be terrible, but we can do this. For example, let's say that capital X of S is equal to, I don't know, 3 over S minus 9 times, I'm just making stuff up here, 1 over s squared plus 9 quantity squared. That's my x of s. 3 over s squared plus 9 times 1 over s squared plus 9 quantity squared. So here's your first function, capital F of s. That's the thing in the first set of parentheses. And your capital G of s is the thing in the second set of parentheses. We've got a capital F of s and a capital G of s. Front part of your book or your chart, come up with what little f of t is and what little g of t is. So go front part of your book, come up with what each of those are. If I did it right, they should each exist in the front part of your book. What's your little f of t? What's your little g of t? First one's a little easier to find than the second one. First one should be 3e to the 9t. That's a 9 and not an a. 3e to the 9t, first one. And then second one should be the messy one. Sorry. So second one should be 1 over 2 times 3 squared. And then we've got, where is it? Sine of 3t. Go ahead. What did I screw up?
It'd be 3 cubed, I think.
3 cubed, not 3 squared. I can make that into a cubed. I'm getting better on a whiteboard. 3 cubed. See, that's what it says. 1 over 3 cubed. Sine of 3t minus 3t cosine of 3t. Okay, so therefore, little x of t, and we are absolutely positively not doing this, but little x of t is the convolution of little f of t and little g of t. There is no way I am doing that integral for you. I wouldn't even do that integral for myself, but that would be what you would have if you would want to find the inverse Laplace transform. And if you wanted to, we could write this out. I won't write it all out, but integral from 0 to t. I definitely want to plug the t minus tau into my f in this case. That's totally where I want to plug the t minus tau. So f of t minus tau, g of tau, d tau. I do not want to plug the t minus tau into my g. That's just going to be a disaster and a half. I mean, it's a disaster and a half anyway, but that would be even more of a disaster. So not doing that integral, but you could if you wanted to. Any questions, Stuart?
So then just in that f of t minus tau, it would become like 3e to the 9 quantity t minus tau.
Yep.
Okay.
Yep. And then the g of tau, you just substitute a tau every place you see a t. But yes, that would be your f of t minus tau. That would be your first part there. Okay. Anybody else? Other questions before I stop sharing my screen with you for real this time? Anything else? Okay, stopping screen share. That is a good place to end for today. So we're done a little early, but that's okay. Next time, what we're going to talk about is how you can use derivatives and integrals to help you out with finding inverse Laplace transforms. For the 829th time, step 3 is hard. We're looking for techniques to help us out with step 3. And we came up with convolutions today. On Monday, we're going to talk about how you can use derivatives and integrals to help us out. So that's Monday. Any other questions? Homework due Monday, next test Friday, April 17th. And I will hopefully get you a schedule for the rest of the semester this afternoon or this weekend. Any other questions? that you have. Abby.
Okay. This is on what we just did. Sorry.
Okay,
I was
that's
trying to
okay.
write it down before.
That's okay.
So if you go back to the example, the 1 over s squared plus 9 quantity squared, that whole thing.
Sure. This one. That's a disaster and a half. Yes.
Okay.
Yes.
So. Oh wait, never mind. I just wrote down wrong.
Are you sure?
Never mind, it's fixed. Yes.
Good? You sure?
Positive.
Okay. It's a lot to write down.
Sorry.
That's okay. Not a problem. All good. Okay. Anybody else? Other questions before we finish? Anything else? Okay. How are you doing with homework? Do you want me to divide you into breakout rooms so you can talk to your homework partners? I will not be insulted if you say no. Anybody need it? You can say no and I won't be insulted. I'm getting some no's. I'm getting some we're okay. We have other methods of communication. We're fine. Okay. Last thing for real. Math classes for next semester. Take a look at your schedule. I'm more than happy to go over scheduling things. Stuart and I are going to talk about it after class. If you want to let me know when you have some time, if you want to talk about it, I'm more than happy to. If you are a sophomore and you are intending to declare a math major and you have not yet declared a math major, you should do that. Grant, how easy is the process to declare a major? Sorry, I called on you and you weren't ready.
Really easy.
Thank you. Really easy. All you got to do is fill out a fillable form online. So if you are thinking about it, let me know. I will walk you through the steps. It is really easy, promise. But look at what classes you want to take next semester. The schedule is on my WLC. All right. Anything else before I let you go for the weekend? Grant, yes.
I will say though, make sure you follow the directions because you have to download something to sign it,
Yes.
which is easy, but just follow directions.
Read the directions is always a good thing to do. Yes. Anybody else? Going once, going twice. Okay, I'm going to stop recording then.